Hello. In this lesson, I like to just talk about how to find a vertex as a topics. Finding vertex, we already talked about two methods, right? And we're going to recap on the two methods we did. And then we're going to talk about a third method. Hope all of these methods will help us to gain some more insight about these methods and along the way improve our algebraic skills. The first method we did, right? The first method we did is that we assume, right? We assume that we got the, we have this form already, right? So we assume this is the form, and then we set out to find A, H, and K. Okay, this method works pretty well. Okay, of course, we always end up with the same answer, right? Example number one. Example number one, right? This time I'm going to use a slightly different example, right? Say this one we're going to be working with, right? We have a function, right? So all of these questions, all of these examples we're going to do is find vertex. So vertex is our goal here. So this is very focused topics, okay? Finding vertex. And here we have a question, right? And this question we have x squared, okay? X squared plus 6x, okay, plus 7, okay? So using this method, right, so we assume, okay, so we make assume that we already find those, we assume that we're going to have this form. Okay, we assume we already have this form. And A is going to be the same as the number in front of x squared. So in our case, A is 1, right? So we just have to find H and K. So from this identity, from this assumption, right? From this assumption, what we're going to do is that we're going to FOIL the right-hand side. Okay, so we're going to have the right-hand side, left-hand side stay the same without changing. And the right-hand side, we just have x squared minus 2hx plus h squared plus k, right? You can see on the left-hand side, we have x squared plus 6x plus 7. On the right-hand side, we have x squared, and we have negative 2hx and h squared plus k. So there's a correspondence here, x squared, they're the same, right? So we can subtract them, where they already have the same coefficient, we don't need to worry about it. And the other one is the coefficient before x, right? They must be the same. So then we got, right? Then we got negative 2h is equals to 6. Right? As a result, if we divide both sides by negative 2, we get h equals to negative 3. Right? Because these two are equal, therefore the coefficient in front of x are going to be the same. That's how we get negative 2h equals to 6. And secondly, that h squared plus k should also equals to 7. Okay, so from comparing the coefficient for x, we got that equation, and from equalizing the constant, so we get 7 equals to h squared plus k. Since we already know h, right? We already know h. So we just plug in the value for h. And h equals to -3. Okay, we can omit the positive sign in front of it. And we can solve for k. Then we're solving for k. So in this case, k is equals to, subtract 9 on both sides, k equals to -2. So we found h and k. So h comma k is equals to, right? H is -3, k is -2, and we found it. And in terms of the final solution in the complete square form, right? With a perfect square form. So this expression will be written as h. H is -3, right? K is -2. Right? So in the end, we got x plus 3 squared minus 2. So we got the form in quadratic form that there's a perfect square in it. So this is the first method. You see, if we look back to the first method, we just assume such form exists, which it does, always does. And we just, expand the right-hand side and compare the coefficients, right? 6 equals to -2h, and the constant piece equals to the constant piece. So that's how we get h and k. The second method, right? The second method is a completing square part, okay? So the second method we're going to do is that we did a lot in the previous lesson, but here we just want to review it, right? So method two. For method 2, in our case, this is very commonly talked about, okay? You see this in a lot of literatures, textbooks, and you also continue to see this in actually calculus text, okay? So we got x squared plus 6x, right? And we're gonna plus something and subtract something, right? So we're gonna take the 6 divided by 2 and then squared. And then we have a plus 7. And this is not gonna work because we have an equal sign. We add in a number. So we have to subtract the same number to make it a balanced. Okay, so this latter expression still equals to the former. Okay, so we must guarantee that. And then, so we understand that the first part is to make the perfect square. And the second part is to keep the equal sign validated. So of course, this is 3 squared and this is 3 squared. 3 squared is 9, so you can write 9 here, right? And the next step, we got the perfect square already. Okay, we got the perfect square already. So this part is equals to x plus 3. Okay, factor this piece, right? Factor that piece. We got a minus 9 plus 7, that's going to be minus 2. So we got the same answer as you see. So this is a method 2. Okay, method 2 basically is algebraic manipulation, and we use mathematical principle. Anything at 0, right? Anything at 0 stay the same. Okay, we use that principle. Method 3 is what we're going to talk about today. Method 3 actually is more, I would say, we use more graph and our imagination. Okay, because first of all, we make observation about the parabola we're talking about, right? For example, we still use the same example to do method 3. Okay, so I'm going to show you Okay, the third method is very much, drawing pictures, plotting points along the way. Okay, the first thing we do is that we know that this parabola, okay, this parabola opens up. Okay, so parabola opens up. If this parabola opens up, so we know that it's going to it's going to have a lowest point, right? It has a lowest point. The vertex, we assume that the vertex, of course, as always, the vertex is going to be HK. Okay, we don't know what it is. Okay, and one of the things we can find out is that we're going to assume that f of x, we have this function, we can find y-intercept. We can find y-intercept by substituting x by 0. Okay, so this is a way to find y-intercept. Okay, and of course this equals to 7. So what we have found, we found a point on the curve, 0, 7. Okay, so now with 0, 7, we can draw a picture. We can draw a picture now, okay? Because we're gonna imagine, well, not entirely imagine, we're gonna kind of guide us by looking at the picture and to see what we get. Okay, so here I'm going to just plot the point we just got. Okay, the point we just got is y-intercept, right? So for this y-intercept, right, what I'm going to do is I'm going to put that point on the graph, 0, 7. 0, 7 is going to be a red dot on the picture. And of course, we don't see it now because I need to modify the view. Okay. 8, right? So 0, 7, right? You see, I have 0, 7 on my picture, and I'm going to mark it. So 0, 7, and this is the point. I would say 0.25, and here I'm just going to put something like that. Okay, so I will mark the point on my picture. So if you do it on paper, please do so. Please do so. So 0, 7 is my y-intercept. But what I don't know is that I know the curve is going to pass this point, but I don't know if it's going this way or going the other way. We don't know. That's to be found. Okay, it opens up. It opens up, right? And we have no idea. So what are we going to do next? What do we do next, right? The next, I'm going to draw a horizontal line, passing the y-intercept. Okay, I'm going to draw a horizontal line. So I'm going to show you. Okay, I'm going to draw a horizontal line. Okay, y equals to 7, right? Drawing this line, So this line definitively is going to cross the curve, but we just don't know which side. So I need to find, I know there's one point on the curve. I just have to identify another point. So for that reason, I'm going to take the function. Okay, I'm going to take the function and I'm setting the function equals to 7. Okay, so I basically say, all right, I'm going to set the function equals to 7. Set it equals to 7. What does that mean? Set it equals to 7. We know that we're given an output, right? So we want to find all the input such that, the function equals to 7. So I assigned an output equals to 7. Okay, and we want to, okay, so I'm going to put it here as a note, so you don't have to write it here, but in your mind, that's what we're doing. We draw this horizontal line to cross the curve. We don't know where the curve is. We don't know which direction it goes. And of course, you can say, oh, we can just graph it, right? Now, I'm going to solve this equation. Okay, so I'm going to solve for x. I'm going to solve for x. This will guarantee we'll have a solution. Okay, so we're going to solve for x in this equation, in this if statement. Okay, so basically we're saying if the output is 7, how many input could I find? How many input could I find, right? And there's a +7 on one side, +7 on the other side, so subtract 7 on both sides. So I will have x plus 6x equals to 0. And then I can solve this equation very easily, right? So I'm going to solve this equation very easily. So factor, so x plus 6 multiply x, and that equals to 0, right? According to principle number 5, we get x equals 0 or x plus 6 equals to 0. So in the end, we get x equals 0 or x equals to -6. Okay, so now we got the points. We found the points. So these 2 points are, right? One is 0, the output is 7, and the other point is -6, 7. You see, we already have 0, 7. We already have 0, 7. So the other point is -6, 7. So this way we know the curve is on the other side. Okay, so I'm plotting this other point, and we know this point is on the curve. Okay, that it doesn't show, I need to make some adjustment to make it showing that. Here you go. Okay, so now we can clearly see the curve is going this way and going up. We don't know where we still don't know the vertex, but we're getting closer. Okay, we are getting closer for sure. So this point is 0, 7, and the other point is -6, 7. Okay, so I'm going to mark the other point, -6, 7. Okay, and this point is right there. Okay, we're gonna put that point in place. So you can see -6, 7, and here is 0, 7. I should move 0, 7. It's just a little bit murky. So I'm going to make it like this. Just be better. Still not as good as I wished. It's just one more try. Okay, I think you guys see it. Okay, so point 0, 7, -6, 7. You see they're at the same level. Both point passes the curve. Both point pass the curve. So our curve we can guess. Right now our guess is way better. The curve is going like this, right? We don't know if it could be going like this. We don't know, right? It could be going like this. It could also be touching the curve once. We don't know. We really don't know. But anyway, so we're closer. Why are we closer? Because we know that there's a line of symmetry right in the middle, right in the middle. Okay, so that X is going to be the middle of -6 and 0. So how do we find that number? Right? So between 0,7 and -6, 7, I'm going to bring that picture down here. Right? The H is going to be equals to half of 0 plus -6. So that's the middle point. That is the middle point. So we get -3. So we found H. You see that? We found H. So the H is right in the middle. It's that line of symmetry, and H equals to -3. Okay, so I can put the point. Now we're just so much closer to what we wanted. Okay, we're so much closer to what we're looking for. So we found H. Okay, and this is going to be the line of symmetry. Let me use the line of symmetry with a brighter color, right? So this is the line of symmetry. And the point we get, right? This is H, right? So this point is in the middle, right? This is the point we have identified, which is -3,7. Okay. We don't have to mark this point, but just for the fun of it, so you can see better. Okay. So it's a -3,7. I'm going to use the green dot just to show, well, this point is not on the curve, but it's on the line of symmetry. So if we mark that point, so you will see better. Okay, so -3,7. -3,7. So here I'm going to put negative. And here 7.5. Just to mark the point properly so you can see well. So that's a -3,7. I'm going to move it just over, move it over just a little bit. Okay, so move it over, make it, oops, -3,7. I'm going to move it over to over here. Let's see how that works. Yeah, this is better. You can see that we first find the y-intercept, and then we draw the horizontal line, and so we hit the other point. So the point in the middle will give us the vertical line of symmetry. Once we find the line of symmetry, K is equals to F of H. Okay, so what is our X? What is our F of X? So we found this number by plugging in the number H. So H equals to -3, and this X equals to -3 here, right? And this X equals to -3. And we just operate, right? And so that equals to 9. 9 minus 18 plus 7. So in the end, we get a K. And that K is equals to, this is -9, -9, right? Plus 7, it's -2. So K is equals to -2. So by this time, H and the K is found. So that's going to be -3, -2. So we found them. We found them, right? So this is the way that we can find the vertex. You don't have to do complete a square, right? You just use these techniques. Use the symmetry, okay? The property of symmetry with respect to a certain line, so we can find the vertex. So now we can connect the dots. We can connect the dots, right? Then you say, can we find X-intercepts? Of course you can find X-intercepts, right? From here, you can certainly find X-intercept. But here, of course, we want to find the vertex, right? So we're not, we're not focusing on finding X-intercept. We're focusing on finding the vertex. So here we go. We found the vertex. So vertex is found, right? And if you like to do the graph, right? If you like to do the graph, and then you can just do the graph. In this case, and most of the other cases, right? In most of the other cases, guessing the point can be hardship, can be difficult. Okay, so these steps will guarantee you're going to find the precise number. Okay, so I'm going to talk about another method. Okay, this method is going to be for a specific type of equations. Okay, so let's look at example number 2. Example number 2. Okay, we also finding this is also to find the vertex. Okay, so what we have here is that we have x minus 3 multiply x plus 5. Okay, in this function, right? It's a quadratic function. Of course, you can FOIL it, right? You can FOIL it. You get this form, right? But since you already have the factored form, right? And you can also use the method in the first one, but here I'm going to use it. I'm going to do it differently. Okay, I'm going to start out to find X-intercepts. X-intercept. And I know there are 2 X-intercepts. There are 2 X-intercepts. How do I know? Because if I find X-intercept, I'm going to have to set output equal to 0, right? So I'm solving for X. I'm solving for X. Okay, I'm solving for X. I'm solving for X from here, and I will get, using principle number 5, I get x minus 3 equals 0, or x plus 5 equals to 0. So I get 2 solutions, x equals to 3, or x equals to negative 5. X equals to negative 5. Okay, what does this mean geometrically? I got 2 X-intercepts. Okay, so if I am to draw a picture, okay, even if you don't draw this picture, you probably will vision that you have 2 points of X-intercepts. Okay, and what are these 2 points? These 2 X-intercepts are, right? These 2 X-intercepts are like this. They are 3, 0, and the other one is negative 5, 0. See, right? So can we put these 2 points on the graph? Of course. Right, so we're going to put these 2 points on the graph. The first one, we have a little red dot, right? And the second one, we have another dot. There we go. All right. What does this tell us? What does this tell us? This tells us, right? The curve crosses, well, this obviously opens up, right? It opens up. If you FOIL, it's going to be, you're going to have a x squared before x squared is 1, right? So it opens up. So the curve is going to go like this. Okay, the curve is going to go like this. Okay, passing these two x-intercepts, right? Of course, my drawing is pretty ugly, but you got the idea. So there's a line of symmetry. There's a line of symmetry. Okay, so our h is equals to half of 3 and -5. So 3 plus -5, just like the previous example, divided by 2. So that's the middle point. So you see 3 plus -5 is -2. -2 divided by 2 is -1. So we got h. Once we got h, k is equals to f of what? H, right? And that's how we find it, right? So what is a -1? 0, right here. If I mark that point, right? -1, 0, that's in the center. That's in the center, and that's where the line of symmetry lies, passes. So the line of symmetry is going to be like this. Okay, so that's the line of symmetry. Here you go. That's the line of symmetry. So a curve is going to pass it. I'm sorry, the curve is going to cross it, cross the line of symmetry. So we just have to find the k. So what is the k? What is the k? The k is equals to f of -1. And what is f, right? We have f here. So we can just plug in x equals to -1, x equals to -1, right? And we got, this makes -4. -4 times +4 is -16. So h and k, the vertex is found. H comma k is equals to -1 is for h, -16 is for the k. And I can put this point in the picture, right? And I need to put that point in the picture. It's a red dot, it's on the curve. And of course I need to make adjustment. You don't see it because it's not in the picture. And right here, there you go. So that's the line symmetry. Obviously we have to, if you graph this, you just have to constantly adjusting it, right? So here I need to extend the line of symmetry. Okay, so that should do it, right? And we need a little bit more on the, say, 8, right? So this picture will be more balanced. So the curve goes like this, right? So now we can graft it. Now we can graft it. Just connect the dots. Just connect the dots. And you can see the curve passes these x-intercepts. So we basically use the symmetry to make these pictures, to find the vertex, okay? So the symmetry of parabola really plays an important role, okay? Now, in fact, any 2 points on the curve, right? As a matter of fact, any 2 points, any horizontal line you draw, you can find it. You can find it. Okay. Then these 2 questions are essential. These 2 methods we did here, they're really just one method. It's just which horizontal line you use. If you draw any horizontal line, you cross the curve in the middle, you're gonna have the line of symmetry. You're gonna find the line of symmetry. So it doesn't matter how you draw it, really, right? So, but why we use the first method, right? If we go back to see the first method, right? the way we set up, we make it equals to 7, right? We make it equal to 7. So we ended up with an equation which is very easy to solve. Very easy to solve because you factor it and you found the solution already. And you only need one more solution, right? You already have one. So this is a good idea to find the 2 points. But in fact, you can find any 2 points, really. You can find any 2 points, okay? So hopefully these 3 methods, I hope you master all 3 methods, okay? That will be the best, okay? If you have to master the second one, the first one, the third one, they all have their own merits. If you can master all 3 methods, and you are really improving on your understanding about quadratics, okay, which is a very, very important function in your academic career studying mathematics, right? I know mathematics is part of your requirement, but since you are studying, you may just as well to make sure you understand it more thoroughly. Okay, so without further ado, if you have any questions, so please don't hesitate to ask, and thank you for watching.